Alright guys, today's goal, the learner will be able to define and use sequences and series. Okay? A sequence is a function whose domain is a set of consecutive integers. If a domain is not specified, it is understood that the domain starts with 1. The values in the range are called the terms of the sequence. So see how it starts at 1, and then you get the first range, 2, second range, 3, third range, 4, fourth range, and then all the way it keeps going on. A finite sequence has a limited number of terms. An infinite sequence continues without stopping. A sequence can be specified by equation or rule. For example, both sequences above can be described by rule a sub n equals 2n or f of n equals 2n. So a sub n and f of n mean the same thing as what that's saying. Okay? So it says write the first 6 terms of the sequence. What that means to do. A sub 1 equals 1 plus 4. That means n is 1. What do you get? 5. A sub 2. 2 plus 4. 7. A sub 3. Or 6. A sub 3. 3 plus 4. 7. A sub 4. 4 plus 4. 8. A sub 5. 5 plus 4. 9. A sub 6. 6 plus 4. 10. So the way we write the final answer for this, you go 5, 6, 7, 8, 9, 10. Okay? So for this one, you have to find f of negative 1, or not negative 1. One, 2. So f of 1, f of 2, f of 3, f of 4, f of 5, and f of 6. So if you plug in 1, you get negative 8. If you plug in 2, nope, I'm sorry. Negative 2 to the 1 minus 1, 1. Negative 2 to the 2 minus 1, negative 2. Negative 2 to the 3 minus 1, positive 4. Negative 2 to the 4 minus 1, negative 8. Negative 2 to the 5 minus 1, 16. Negative 2 to the 6 minus 1, negative 32. So the final answer here. 1, comma, negative 2, comma, 4, comma, negative 8, comma, 16, comma, negative 32. See the pattern here, positive negatives, and they're doubling. Okay. So this one, you get 1/2. A sub 2, 1 plus 2 plus, or no, 2 plus 2 plus 1, 2 thirds. A sub 3, 3 over 3 plus 1, 3/4. A sub 4. 4 over 4 plus 1. 4/5. A sub 5. 5 over 5 plus 1. 5/6. Hopefully you start seeing the pattern here. A sub 6. 6 over 7. So if you look at this, the top number is always increased by 1, the bottom number. So our final answer here, 1/2, 1/3, or 2/3, 3/4, 4/5, 5/6, 6/7. The top just was increasing by 1. The bottom was also increasing by 1, but it started 1 ahead. Okay? Alright, so now let's move on and see what we have to do. Alright, so for the sequence 3, 8, 15, 24, describe the pattern, write the next term, graph the first 5 terms, and write a rule for the nth term. Okay, so we have a lot to look at here. So here's the thing. We know a sub 1 is 3, a sub 2 is 8, a sub 3 is 15, a sub 4 was 24. So we have to think 1 times what or 1 plus what equals 3. And then check. 2 times what or 2 plus what equals 8. In order for be adding, it's got to stay the same. So I know that would be a 3, and then that would be a 2. Here I'd have a 4 and a 6. So did adding stay the same? No, so we have to get rid of those. Let's look at the multiplication. It goes from 3 to 4. And then 3 times what equals 15? 5. 4 times what equals 24? 6. So we have to figure out a pattern here, because there's got to be something. Well, how far apart? That's the n. Those are all the n's. How far apart from the n is the 3? Well, 2. How about from 2 to 4? How far apart are they? 2. 3 to 5, 2. 4 to 6, 2. See how they're all 2 apart? So couldn't I say that's n plus 2 then? So there's our rule. So we have a sub n equals n times n plus 2. Okay? So we got the nth rule. Now it says write the next term of the graph. So they want the 5th term. So we're going to have to graph at some point. So a sub 5. 5 times 5 plus 2, 35. That says graph the first 5 terms. So there's our rule. There's the next term. One, 2, 3, 4, 5. These are the n's. 5, 10, 15, 20, 25, 30, 35. Those are the values. So instead of x and y, it's the n and the terms. Okay, so when n was 1, we got 3. So it would be about there. When n was 2, we got 8. When it's 3, we got 15. When it was 4, we got 24. When it was 5, we got 35. That's approximately what the graph is. You don't connect it. Okay? So we have to be able to try to figure out patterns. Okay, so let's look at another one. Okay. Same directions. 4, 8, 12, 16. So 1 plus 3 is 4. Is 2 plus 3 8? No, so we can't. So look at multiplication. So ask yourself, 1 times what equals 4? 2 times what equals 8? Because it always starts where? It always starts with n equal 1, n equal 2. Like those are the first two terms. This is when n is 1. That's when n was 2, n was 3, n was 4. 4. 4. Is 3 times 4 12? 4 times 4 16? Yes. So you're multiplying n times, it's n times 4 because it's the same. So you have 4n. So find the next term. We have to start recognizing patterns. And I want you to graph it. Remember, those are the ends. You don't always have to do scale of 5. I was just trying to make it easier. So 1, 4. 2, 8. 3, 12. 4, 16. 5, 20. Okay? All right. So you work in a grocery store and are stacking apples in the shape of a square pyramid with 9 layers. Write a rule for the number of apples in each layer. So again, think about it. See, it tells you the first 3 layers. When n was 1, we got 1. So when n is 1, you have 1 apple. When it's 2, you have 4. When it's 3, you have 9. So let's look at this. 1 times what equals 1? 2 times what equals 4? 3 times what equals 9? Well, that'd be 1, 2, and 3. Yeah, it's increasing by 1. So if we think about the other one that increases by 2, we said, well, no. It's actually, that's n and that's n. That's n and that's n. So what is it? N squared. So our rule, a sub n is equal to n squared. And then 9 layers. So also find the 9 layers. Find the 9th layer. So a sub 9 equals 9 squared, so there'd be 81 in the bottom. Okay? All right. So now we need to look at series and summation notation. This symbol means sum, the sum of. When terms of a sequence are added together, the resulting expression is a series. A series can be finite or infinite. finite series, 2 plus 4 plus 6 plus 8. So the sum of that would be 20. An infinite series, see how they have these three dots? It means it keeps going forever and ever and ever. You can use summation notation to write a series. For example, the two series above can be written in a summation notation as follows. 2 plus 4 plus 6 plus 8. Okay, that's 2 times I. They're using I instead of N. You can use N if you want. Okay? And see how there's 1, 2, 3, 4 terms? That's why they have 1 and 4 there. And then same thing here. It starts at 1, goes to infinity. Okay? For both series, the index of summation is I and the lower limit of summation, meaning 1. The upper limit is 4 for the finite series, and infinite for which is the infinity for the infinite series. Summation notation is also called sigma notation because it uses the uppercase Greek letter sigma, written as this. Okay? So, we have to find the rule. So write the series using summation notation. So find the rule. So if you think 1 times what equals 5? 2 times what equals 10? 3 times what equaled 15? So if this is n, and that stays the same, you have the rule as being 5n. So I now know I have this much, or 5i, but, or you could say, yeah, I'm just going to say 5n, n equals 1, because we always start at 1 with these. Now we have to figure out what makes it 100. So say 100 is equal to 5n divided by 5. N equals 20. 20 goes on the top. Okay? Alright, so write a series using summation notation. Okay, so anytime it's a fraction, look at it as two separate things. Figure out the pattern for just the top and just the bottom. Okay? So let's look at this. If I look at just the top, I have 1, 4, 9, 16. That should pop out at you because those are all perfect squares. So if you think about it, isn't it 1 times 1 equals 1? 2 times 2 equals 4. 3 times 3 equals 9. So you have n times n. So for the top, we have n squared. Okay? Now, for the bottom, now we're looking at 1 times what equals 2? 1 times what equals 3? Or 5? 1 times what equals 10? So here I get 2, 5, and 10. So there's no real pattern here. And that one's 2, 3. That one's 1 apart, 3 apart, 7 apart, so there's no pattern there either. But look back at the beginning now. What's the difference between the top and bottom of the fraction every time? 4, 5. What's 1 plus 1? 2. What's 4 plus 1? 5. 9 plus 1? 10. So we just had to identify patterns. So we're including the top, but we're adding 1. So that's what goes here. Does it end? No. So you just put the infinity symbol up there. So there's your final answer. Okay? All right. Special formulas for series with many terms. Finding the sum by adding the terms can be tedious. Below are formulas you can use to find the sum of 3 special types. So if you see these 3 types specifically, we can use these. Do any of these say 8i? This says 1, this says I, this says I squared. So that says 8i. So no. So what do you have to do? Find the first 5 terms. So 8 times 1 is 8. Then 8 times 2, 16. So you have 8 plus 16 plus 24 plus 32 plus 40. Add all those together and bring that in completed tomorrow. So 9, see how it says from 3 to 7 here? That means you have to start by, watch, 3 squared minus 1, 8. And then I'd go to 4 squared minus 1, 15. So find me the sum of the rest of that. Okay? And bring that in completed tomorrow. Now number 10, or Monday I should say, I guess. Number 10. N equals 1 to, see how it says N? Doesn't this up here say just I? Just I right there. So it says to do N, meaning the top number. See how it has N at the top here? So 6 times 6 plus 1 divided by 2. 6 times 7 divided by 2, so the sum is 21. Okay? So just remember to finish 8 and 9, and I'll see him tomorrow, or Monday.